So it tells us to find the remainder of this polynomial. And you do see the keyword divided by, and you see the remainder. Now it may not give you the hint of the remainder or division. I just might show you a division sign, right, and divide it, and might ask you a different question. But when you think of the remainder, you're thinking of taking this value, and when you can either do a couple of things. What are some things you can do?
Long division.
You can use long division. Let me write that out. Long division. Raise your hand if you did that. It's okay if you did. Probably not fun. What's another way?
Synthetic.
Okay, you can use synthetic division. Okay. But you can also use the remainder theorem. Raise your hand if you use that. Now, the nice thing about that is that all you have to do is do what with each of these? Set it equal to 0, add 1 to both sides, and I have x equals 1, x equals 2, and x equals. And of course, if you were actually showing your work, I do want you to do the substitution into the polynomial and actually show me. But for our purposes, I can just double check my answer with the calculator. I just go to y equals, type in my function there, 2 times x to the third plus 3x squared minus 17x minus 30. One student did ask, what happens if I'm missing a term? Let's just say this is not here. Do I have to write 0x? The answer is no. Because if you wrote 0x, 0 times anything will just be what? 0. So I have this polynomial. Now I can go to my table by pressing second graph, and I can just type in these numbers. 1. What's my remainder, class? Raise your hand if you got negative 42. I type in 2. Raise your hand if you got a remainder of negative 36. And x equals 3. I have a remainder of 0. Question?
It was a x minus 1, not x plus 1.
Did I write it down correct, class?
Yeah, it was x plus 1. Okay.
This was x minus 1. Remember, you're setting equal to 0 and you're getting the term x equals 1.